we are going to think of doing transformations in the reverse order. So what's going to happen here is, on the left-hand side is your usual transformation. Can we think about the reverse transformation on what we have done? Which means, for example, the first one is you translate 1 unit positive x direction, means you have shifted right by 1 unit. If I want to undo, think of it as you want to undo this step, you want to reverse it. What would you do? You will move leftwards by 1 unit. So can we write in words first what this is going for? Translate 1 unit in negative x direction. Then we have scaling. So if I scaled by factor 2 parallel to x-axis, it means I have times 2 to all the x. If you would like to undo this step, this is basically stretching the graph, expanding. If you want to undo, you will compress it back. To compress it back means you times half to all your x values. So we will scale by factor half, parallel to x-axis. Last one, reflection x-axis. This one I want to draw so that you can visualize a little bit. Let's say you had this graph. You reflected, so it went down. How do you get back the same graph? You will reflect the same axis and go backwards. Same axis. So reflection is the special one. When you want to reverse that step, right? Actually, you describe the same way. You still reflect in x-axis. No change, because you're just going backwards on the same reflection, same mirror image. Now, let me show you with the problem. Why is this important for us? It's because we are going to start an equation fx that is initially unknown. I do not know the equation. It's different from the problem just now. Just now, we start with a known. This is unknown. They go through A, B, C, and we reach a final equation. There is a known equation. Your goal is to find out the unknown. So what does that mean? If you want to reverse back the steps, you should reverse who first? C, yeah? Go and start from C. Start here. You want to move backwards now, so you cannot start from A. That's the difference. Start from C and you go backwards. So instead of describing as after A, B, C, this time we describe as before the step. Before C. Before C, what's going to happen? There are two things I would write here so that it's clearer and we avoid mistakes. The crucial part is the question is simple, but we avoid mistakes. Write down the transformation, then write the description. What is the reverse step of reflection y-axis? You still reflect y-axis. But you can write in short form, doesn't matter. The crucial thing is write in the correct replacement. And we understood that this is replace x by negative x. So let's go to this equation. We get it replaced. I simplify my equation first. And then we go for before B. B was a stretch on the x-axis by factor half. The reverse should be you still stretch or you scale along x-axis. I'm going to write in short form. but factor 2. If you had compressed with half, now you expand with 2. And this is your replacement of x by half x. Your replacement is based on the new corresponding reverse step. Okay, we put into our equation. If we can make the following observation will be best. This denominator can actually be factorized nicely as an x minus 1 squared. And last, let's go for before a. When the question says in direction of x-axis, if nothing is stated on positive or negative, by default, they mean positive. In x-axis, so go in the direction of x-axis means the positive side. So we think about the reverse. If it's 1 unit in x-axis, now this is translate minus 1 unit on the x-axis, opposite. Which means we replace x by x plus 1. And we try to answer the question a little bit. They want you to determine the graph y equals to fx. You should write in eventually what is the fx. So this is the graph we have found. Just fill it in. The fx should take on this equation. Oh, by default, if they didn't mention positive or negative, the default will be, I should write here, default will be positive direction. Okay, if it's not mentioned, the default is positive.